Hello, this is Jeffrey Fox here again, and we're going to describe a new section here describing big data use cases, in particular the use cases identified as part of a NIST study. That NIST study happened between June and September in 2013 and was led by Wo Chang, Robert Marcus, and Shaitan Baru. This section has units describing three different things. One is the first unit describes the overall process, which has a lot of aspects. The second unit goes into detail on the work of the use case group and goes through 51 different use cases, trying to give you a feeling as to the exciting way big data is manifested in the real world. The third unit is quite important. It takes those 51 use cases and relates them to technology and also tries to identify common features. This is going to be quite important in understanding why one does certain things and what technologies are applicable in what way. But this here we'll first go through and introduce this NIST process, which was a pretty important activity, which is now being written up and will be published later in 2014. We always, of course, have to remind you what we're doing. We're trying to understand how to use clouds, running data analytics, processing big data, and solving problems, namely the use cases. I would say this motto of this class was quite consistent with all discussions that we had during the NIST process. And some of the use cases we have come from the fields identified on this collage, and some do not. All right, so first we have a discussion of the actual whole process, which is the NIST Big Data Public Working Group. That was the total activity, and it had various subgroups. And the motivation of the process came from a previous NIST activity centered on clouds. And then they had a forum, which was January 15th to 17th of 2013, which sort of summarized where they were with clouds and pointed out that the cloud activity and, of course, other discussions following the identification of big data as a critical issue, critical feature, or thrust, or whatever it quite is. Actually, we will see we don't quite know what big data is. We wanted to know what makes data big. What are the attributes? We have the V's, velocity, variety, volume, veracity, visualization, but it's not clear that everybody agrees on those V's and whether what the size of a particular V has to be to make the data big. In general, I actually don't think we will find that the bigness of data is the critical issue. What's probably more critical is that data is important. And anyway, given we're going to call this whole process big data, we want to know how this process is different from traditional data environments and related applications, because data has been used forever, as we noted. Newton took data to discover his laws. He watched apples falling from trees. That's classic observational science. That has been around forever, and of course Galileo and Pythagoras and everybody else looked at data in order to make a lot of their discoveries. So how is big data different from these older well-established things? So we need to understand what a big data environment looks like, what type of computers it has, what type of software that it has. Many people running computer centers are very anxious to make certain that the computer center runs big data well. And then we need to look at these environments, which maybe are somewhat different from previous environments, which tend to be optimized for either say enterprise applications, databases, or in the science world for simulations using MPI. And then we have to look at what the how we use these existing applications for the different newer big data environments. And then we have to look at what all the challenges are, which are for the science, the technology, and also standardization, which is relevant, of course, for NIST having S in its name. And how can we accelerate the big data juggernaut? So now we come to the actual definition and charter of the NIST big data, that's NBD, Public Working Group, PWG. This started as actually a telephone meeting slash webcast meeting, June 26th of 2013, which was open to everybody, and it which sort of started to define what the whole process was, and it finished with a one-day meeting at NIST on September 30th. It was ironic that that meeting was the day before the shutdown, and that shutdown, although it was only whatever it was, a couple of weeks, had a very significant impact actually on the whole process because it sort of stopped some carefully orchestrated timeline and probably delayed the process by months in the long when everything is counted up. The meeting was basically to this, what you might call to on the 30th, basically summarize where we were, looked at some near-term steps that defines what's called you might call version 1.0 of the whole process, and then sometime coming up in January of 2014, version 2 will be kicked off while version 1 goes through some internal process at NIST to take the white papers and material produced by the working groups and make them into publishable form. So here is the actual charter, which builds in input for this particular field, plus some general features of anything that NIST participates in. NIST is always vendor neutral and technology and infrastructure agnostic. It always goes across industry, academia, and government. It is not it needs to bring, and of course, to make progress, we need to bring these three different communities together. And the purpose was to establish some consensus definitions, some taxonomies, which often go with the definitions, some reference architectures addressing both technology and security, and a roadmap for how to go forward. And the purpose is to allow the various stakeholders, the users, the developers, etc., to pick and choose the best tools and the best infrastructure for their processing and their visualization. And we have to decide whether we want to use clouds or supercomputers or grids or what have you. And we need to do this in a way that maximizes collaboration and integration of ideas across different sources. And of course, so best practice is an emphasis, common practice, which is sometimes the same as best practice, and it includes standards, but that wasn't the major focus of this initial activity. The whole public working group was arranged into 5 subgroups. There was a requirements and use cases subgroup where I was one of the chairs with Joe Paiva and Segi Bayan from Cisco. There was a definitions and taxonomies subgroup led by Nancy Grady of SAIC. There was a reference architecture subgroup led by Orit Levin of Microsoft. Security and privacy led by Arnab Roy of Fujitsu. And a technology roadmap led by Carl Buffington of Vistronics. Now, most of my interest for this class is actually the work of the use case subgroup, which I was leading, because it tells me the 51 use cases which I want to use to motivate big data technology and approaches. However, for the rest of this particular unit, I am going to go through the first the four other subgroups, and then finally the requirements subgroup, and that will then prepare us for another unit, which will actually go through the 51 use cases. So if we look at what we learned, what we learned at the NIST process that was actually compatible with what for instance, I learned at the Big Data Conference in Santa Clara in October 2013. And it was quite striking. One interesting feature I found from this process was the number of people in the process who said they were data scientists. I hadn't realized until that involvement how many people, especially from industry, consider themselves data scientists. Another interesting feature, which you'll see when we come to the actual big data use cases, is that images are a really critical source of big data. This is shown on the right by this standard plot of the number of photos uploaded and shared per day. And we see at the moment in 2013, we have over 500 million images uploaded every day. This is 500 million per day. And the interesting thing is that Flickr is too small to be seen. Snapchat, Instagram, and Facebook dominate the upload of images. But that's sort of the public images. Then if you go to science, we see radar gives you images, and radar instruments are a huge source of images, and there are lots of them. Light synchrotrons, light pours out and basically takes photos of what happens when the light impacts materials. And of course, the phone cameras is what you see on the right. And then in biomedical imaging, when we discuss the applications of big data, in fact, the known largest sort of technical source of images is MRIs and things like that, with 70 petabytes of imagery per year. If you looked at the business interest in big data, a lot of it is focused on what we'll discuss in the actually the third unit of this section when we discuss technologies, which is the so-called Apache Big Data Stack. And business is incredibly interested in this and its support of data analytics and its use of the so-called Hadoop data file system. That was again striking to me that this Apache cloud stack was so pervasively used. And because if you go to the more academic, purely academic meetings, I had not seen that. I got more discussion of things like data movement and data management and the roles of clouds and grids.